go. Math, please. Here we go. So yesterday we learned how to solve general exponential equations, and we're doing the same thing today, except we're having to set them up first using the formulas that you all were tested on. So starting here on number 1, we want to be able to set up and solve exponential or logistic models. Mark started a new blog to write about his travels. In its initial week, the blog had 800 readers in his initial week, 800 readers. From this point on, the number of readers each week increased by 25%. Use an exponential growth model to find the week, in which the number of visitors reaches 10,000 people. All right, so first of all, this is an exponential growth model. We had a nice little equation to represent exponential growth or exponential decay. Do you remember what that little formula was? Yes, so right here, I wrote it down. We have A equals P times the quantity 1 plus or minus R to the T. And so we're going to use that model. It's you can think about it as the amount is, what's P stand for? The initial starting amount, yep. So we're going to use our exponential growth model, and we are trying to figure out the week. So find time. We want to figure out what the time is. And when the visitor reaches 10,000 people, so where does the 10,000 people go? That's the A, yeah. So we want to know when we get to the amount of 10,000 people. So 10,000 people. What was our initial? 800, yep. And 1 plus, what's our rate? 0.25. 0.25. And we're trying to find the time. And in this case, that T represents the number of weeks, since it was growing 25% every week. We're finding the number of weeks. All right, I can clean this up a little bit. Okay, so I have 10,000 equals 800 times 1.25 to the T. Now, how are we going to solve this? Divide by 800. All right, so a couple of zeros cross out there. And so we have 100 over 8 equals 1.25 to the T. All right, what do we need to do? How do we drop our power? Natural log. Yeah, we're going to take a natural log of both sides. Did you say log base 1.25? You can. I just hate doing it because it requires extra button pushing on your calculator. So my power gets to drop down, so I have the natural log of 100 over 8 equals T times the natural log of 1.25. And then how do we get the T by itself? Divide by the natural log of 1.25. All right, so those natural logs cancel out, and my T is isolated. And so in my calculator, I have to be pretty careful, but 100 over 8, and then divided by the natural log of 1.25. And so it becomes, T is approximately, find the week in which the number of visitors reaches 10,000 people. So it's approximately 11.3. That'd be about 12 weeks. The 12th week. So the 12th week. Okay. All right. Number 2, a new stock entered the stock market in January 2012 at 0.72 cents 72 cents per share. 4 years later, the price per share was $3.85 using a continuous exponential growth model. Find the growth rate. So continuous exponential growth model, what model are we using? PERT. We are using the PERT model. So A equals P e to the RT. Let's see. Again, we started at 72 cents per share. Where does that number go? And that's your P. Yep. So 0.72 and then E. Let's see. It says 4 years later. Where does the 4 years go? Yeah, So that's our time. So I can put that in for the time there. Let's see. The price per share was $3.85. So where does the price per share go? That is the A. Very good. So that would be $3.85 is the A. And it says find the growth rate. Oh, that's nice because what are we missing? The rate R, and that's what we're trying to find. So that's find R. So that's the thing we're going to figure out here. All right, we've got it set up. What should we do to solve? But first, there we go. Divide by 0.72, divide by 0.72. Is that going to give me something nasty? 3.85 divided by 0.72. Ooh, yuck. Funny. All right, that's 385 over 72. 385 over 72. I'm just going to leave it like that. Equals e to the 4r. So then we can do what? Natural log both sides. That's going to allow my power to drop down in front. Natural log of e becomes a 1, yeah. So we have the natural log of 385 over 72, because I'd rather not carry a billion decimals, equals 4r times the natural log of e. But as Wyatt said, the natural log of e is just 1, so that goes away nicely. And then how do you get r by itself? Divide by 4, divide by 4. So r equals, let's see, the natural log of 385 over 72 divided by 4, and that is 0.41914-ish. Okay, but that says a decimal, so what is the growth rate? G-R-O-W. Yeah, I would go, so we want to move the decimal 2 places back, so it's a percentage. So 41.91% or something. I don't know how many decimal places we want, but that is your growth rate right there, 41.91%. That's actually, it's about what we put when we moved here, right? We had a bunch of equity from our house that we sold in Tucson. And so we put like 30 grand into Vanguard stocks. It's doubled. So, in 4 years, it's good. That's what you got to do. Of course, actually finding that money to do that is really, really hard. So we get our tax return, like we always file really fast because we get a lot of money back usually. And so I get to buy furniture, which is always exciting. But my rule is I can only spend half of it. So I get to buy a little bit, but then the other we put into retirement accounts. So that's always a good rule. Okay, I want to do number 3 because I do think you have one, and it's kind of an interesting one. We've talked about half-life before, so I'm going to show you how to think about this. A certain medicine has a half-life. So half-life, meaning we lose 50%. We lose 50%. But we don't lose it every day or every week or every year. We're losing 50% every 5 hours. Okay, so what happens here? This is exponential decay, all right? And so I'm going to use my exponential decay model, but it has a slight modification in the because we are only decreasing every so often. It's every 5 hours. So it's not just the full time, it's per 5 hours. Okay, so that's the tiny change when we're talking about half-life. Let's see. So we started, a patient is given 500 milligrams at noon. So where does the 500 go? P, that's the P. At noon, at what time will they have 100 milligrams remaining? So where does the 100 milligrams go? That's the A, good. In their bloodstream. So we're figuring out at what time. So we're trying to figure out T. Let's see. So A we said was 100, and P was 500. And then 1 minus our 50%. 0.5, yeah, so 0.5, and then T divided by 5, and that's time because it's going to decrease every 5 hours. So per 5 hours, it's going to decrease again. And so that's it. When we have half-life and they have that little thing of time lapse, we just divide by that, and works good. What should we do first to solve for T? Divide by 500. The zeros cross out, so we get 1/5 equals 0.5 to the T over 5. Natural log, both sides, good. That's going to allow my power to drop down. And so I have the natural log of 1/5 equals T divided by 5 times the natural log of 0.5. All right, what do you want to do? Divide by? Divide by the natural log of 0.5? Okay. And then, yeah, okay. So I'm going to do that first. And then, so I have the natural log of 1/5 divided by the natural log of 0.5 equals time divided by 5. So then, Thomas, you said we need to do what? Times by 5. Yes, to get the T by itself. That means there's a times by 5 on top. All right. So now I can plug that into my calculator. So 5 times the natural log of 1/5 divided by the natural log of 0.5. So that is T equals 11.6, and we are in hours. We're talking about hours. So this is 11.6 hours. After 12 noon?
That's about 11:36.
Yeah, about 11:30. How did you get 11:36?
60 times 0.6.
Yeah, this is 6/10 of an hour. So we have to take 0.6 times 60 minutes. 0.6 times 60 minutes is 36. All right. Logistic growth. The nice thing is they give us the model here, so we just have to figure out where stuff goes and then how to solve. So the growth of a plant can be modeled by the equation where h is the height. This is, I think, the best thing you can do when you're reading. They tell you what the variables mean, and it's important to understand what the letters represent. H is the height of the plant in centimeters, and T is the number of weeks since the seed was planted. How many weeks? What are we trying to find? Find T, yeah. So find T. How many weeks will it take the plant to reach a height of 50 centimeters? So that's your H. Very good. All just comes down to reading. So we have 50 equals 250 over 1 plus 12e to the negative 0.72t. How do you want to solve that?
Multiply.
Yeah, so I can think about this as 50 over 1, and we can multiply that denominator to the other side, like cross multiply, if you will. So I have 50 times the 1 plus 12e to the negative 0.72t equals 1 times 250, which is just 250. And then what do you want to do? Distribute? We could. Is there something else we could do?
Divide by 50.
Yeah, we could divide by 50, so we don't have to distribute it, which is kind of a nice thing. Plus it, 250 divided by 50 is 5. All right, so we get 1 plus 12e to the negative 0.72t equals 5. Then what do we do? Minus 1. So 12e to the negative 0.72t equals 4. And then what?
Natural log.
Whoop.
Oh, wait, divide by 12.
Divide by 12. So we have e to the negative 0.72t. 4 divided by 12? 1/3. Now, natural log of both sides. That's going to allow our power to drop down. Follow along there, Scott? No, yeah, I can tell. Negative 0.72t. What happens with the natural log of e? You got lost too? All right, we'll go back. And then we have the natural log of 1/3. All right, let me walk it back here. What happened at the start? Cross multiply. Yeah, that's essentially what we did. We cross multiplied. All right. And I divided off the 50. All right, so we got rid of that. Okay, so we subtracted 1 from both. That gets us to the 4. And then this is 12 times e to the blah, 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 blah. So how do I get rid of the times by 12? Oh, nope. Divide by 12.
Then you do the, okay.
Okay. Good. Okay, so we divided by 12. And that gives me the 1/3. And then I took my natural log. Okay. Natural log of e goes away. It's just a 1, so that cancels out. And how do I get t by itself? Negative 0.72. Okay. All right, so those cancel out, and now I just do my calculator. All right, so the natural log of 1/3, and then divided by negative 0.72. And I get 1.53, maybe 1.53 weeks. Yes. Let's see. How many weeks will it take the plant? It'll take about 2 weeks. Yeah, 2 weeks. I don't know. Either one is fine, really. All right. So this is all just set up and solved. I don't think I need to do another one of those. All right. Okay, so let's go down to compound interest. So the compound interest formula was P times the quantity 1 plus R over N to the NT. All right, so number 6, if $500 is deposited, where does that go? P, that is our principal, yes. Into a retirement account that pays an annual interest rate of 4%. Where does the 4% go? That's your rate, so the R equals 0.04 as a decimal. Compounded quarterly, what does that do for us? That's the N, yeah, so N equals, quarterly is how many times per year? 4, yeah, 4 times per year, all right. How long? What are we trying to find? Find T, yeah, find T is our goal. How long will it take the account to reach a balance of $1,200? So what's the $1,200? The A is $1,200. All right, so now I know I can plug everything in. So we're going to have in place of A, $1,200. Our principal we started with was 500 times 1 plus 0.04 over 4 to the 4 times the time. All right, I'm going to just clean this up a little bit. 1 plus 0.04 divided by 4 is 1.01. So that's kind of nice. And what would our first step be? Divide by 500. Yeah, I'm going to go ahead and divide by 500 just so I can get rid of those. All right, so I get 12 over 5 equals 1.01 to the 4t. Natural log, beautiful. Natural log of both sides. Boys, I sure hope you're paying attention. Do you know how irritating that is? Like, I'm about to blow my lid. Which you've never seen. But I will make you cry. All right. Right? Okay. So I get natural log of 12 over 5 equals what? 4t times natural log of 1.01. And this is 4 times t times the natural log of 1.01. How do we get the t by itself? Okay, that's one thing. We can divide by the natural log of 1.01. Do we times by 4? Yeah, right now it's multiplying with the t, so we want to get rid of it. Also, we're going to divide it. So that's going to go on the bottom as well. So those cross out, and the 4's cross out, and t is alone. Yeah. Oh, but yes, you have to be very careful. So this is one, I would use your alpha F1 so you get the fraction formatting. Okay. Just to make sure that it's good. Oh, oops. There you go. 4 natural log 1.01. Really, these problems, it really boils down to, do you know how to use your calculator or not? 21.9959. 20, that's, I guess, 22, right?
Yeah.
22 years? Yes? Yeah, because we're an annual interest rate. Yeah, that annually means by year. Yep. 22 years to get $700 extra dollars? It's crazy. All right. Let's look at number 7. Number 7, Dave deposited $500 into a savings account. What's that? P. After 15 years, what's that? Time. The account balance had tripled. Whoa, what does that mean? The account balance had tripled. You multiply by 3. What do we multiply by 3? 500. So we would have $1,500. Where does that number go? That's the A. Okay, so the amount after 15 years was $1,500. Okay, with no other deposits or withdrawals, assuming the interest compounds continuously, what formula are we using? PERT. The PERT formula, A equals PE to the RT, because it's compounding continuously. We want to find the interest rate. Find R. Okay. So I want to know when my account balance reached $1,500. That's when it tripled. Started at 500, and then E, we're figuring out R, and this was after 15 years. All right, what do we do first? Divide by 500, which gives me 3 equals E to the 15R, then what? Natural log both sides, so my power can fall down. So I get the natural log of 3 equals 15 times R times the natural log of E. What's the natural log of E? 1. And then how do you get R by itself? Divide by 15. Beautiful. So let's see. I get natural log of 3 divided by 15. 0.0732 equals R. What is our rate? 7.32%. And if you just multiply by 100, you'll get there. Okay, you have questions for me? Is that good? All right. No, worksheet. 25 minutes. Perfect. Nope, that's not you guys.
Thank you.
You're welcome.